In this video, we're going to look at the homework for Chapter 5. So again, what I'm trying to do here is just kind of walk you, unlike the lectures where we don't really get a chance to, look at specific problems, what I'm trying to do here is walk you through specific problems. As I do it, I realize most times I'm actually walking you through directly what the answer is. Most of the time I'll probably just do that. Again, my goal is I just want you to learn the material. I'm not much for making this a mystery novel. And hopefully for those of you who are kind of like, really working through the problems, you don't feel like I'm diminishing the value of your work. Okay, so let's start. And again, what I've done is I've printed out the questions. I didn't really work them out, but I did print it out, and so hopefully as I talk about these, I'm not making too many errors. Okay, so let's start for Chapter 5 here with number 1. We've got a continuous variable x normally distributed, mean of -16, standard deviation of 4. What's the probability that the randomly selected variable will be less than negative 21? Okay. So first, it sometimes is helpful just to think about this graphically, what we got going on here. What that would mean is that we've got a normal distribution with a mean of -16. Now, what we know is that -21 which would be right here, is 1.25 standard deviations away. How do I know that? Because the standard deviation here is 4. So if it was -4, right, that would take me from -16 to -20. And then an additional 1 is 0.25 of a standard deviation. So this is 1.25 standard deviations. And what we can do is we can look at the standard normal distribution here. Let's see here. Okay. So what that gives us here, sorry, just look this up here. .25. Okay, so let's get we need that table. Let's see here. I don't want to lose our pages here. Okay, so sorry, I have to get rid of this. Need to go to the book. Sorry, please be patient with me. And excuse me. I want to look at the book. Oh, sorry, I saw it right as I was doing that. Sorry, I'm doing that because I want to look at the table here that are in the appendix, and I need my cumulative probability. There we go. So, 1 point, sorry, we can make this bigger. 1.25 is right here. So that's a z of 1.25. And if we want it to be less than 21, so that would be 8.944, which would mean that what is remaining here is 1 minus 0.8944. So 1 minus 0.8944 is 0.1056. Let's see if that's the case. I think that is. Let's hope that it is. Okay, at least it's an option. So I think that that's correct. Actually, I can see. Yeah, so that is correct. So, let's just keep doing it this way then. So if you follow my logic there of how I talked it through, you're going to be good to go. Let's go with the next one here. So now I've got a normally distributed variable mean value of 48, standard deviation of 6. What's the value of x star such that the probability is 0.0025. Okay, so what that means, right? So again, I like to try to think of things graphically first. What do we got going on here? Here's our mean value of 48. We have to find the z value. We can solve for the unknown. What we need to do here is we need to find the value of z. So for 0.0025, sorry, I have to exit this. Oy. So what we have to do here is we have to find the value that's 0.0025. So I'm just kind of 0.0025 is right here. Okay, so that's negative 2.81. There's my z value, is negative 2.81 for that 0.0025. That would mean for us here that we can now set up again our equation. Negative 2.81, which I just found from the table, equaling x minus 48 over 6. So 6 times negative 2.1 is negative 16.86. And that's going to equal my x minus 48. So now add 48 to both sides. And x equals 31.14. Close enough. I think we just have a rounding error here. Maybe. Yes, I think so. Here, let me make sure. Sorry, give me a second. I think I've got a rounding error. I'm going to darn well hope so. I know I've solved it correctly, so let's make sure. If you run into this kind of problem on the exam, again, I won't have other numbers that are too weird. Let's hope that that's accurate. Fuck yeah. Okay. Let's do number 3 here. Again, try to follow my strategies here. Try to get a sense of how I'm solving these, applying the knowledge basically from chapter 5. So now I'm looking for the value of the probability for my z-score being between negative 0.63 and 1.51. So we're going to need our table. So we're going to have to find 1.51 and 0.63. Actually, let's just go back here. Negative 0.63 is right here. So that value for negative 0.63 is 0.2643. So let's try to remember that. And then the other one I need to find is 1.51. 1.51 is 0.9345. So what that means that we then do is we're going to have 0.9345 minus 0.2643. So what I'm doing is subtracting the two z-scores. And that's going to equal 0.6702 Okay. Try to remove that 0.6702. Okay. There we go. Okay, let's look at the next one. So here we've got density function, and we're looking for the probability that we're going to have a value chosen at random on interval 3, 6. Okay. And it's between 2 and 7. Okay. So, again, let's start with how this looks. So we're looking for... So we're told that between 2 and 7... So we have 0.2 density on the outside of the 2 and 7. That x is greater than or equal to 2, but less than or equal to 7. So that gives me .8 here, right? Because that would be whatever's left over, because we know that the total area needs to equal 1. And so if we're looking at 3 and 6, and things are, since this is normally distributed for the most part, taking out 2 additional units here, that's going to, we know that the difference here would be 0.1. So that leaves me with 0.6, because it'd be 0.8 minus the 2 intervals here. So, let's hope here. Okay. What must be true of a density function? Oh, this sounds nice and easy. Okay. Well, the one thing we do know is that the area under the curve has to equal 1. That one we do know. What else do we know? Well, we know it can't be below the x-axis. That's just by definition. Value of x must be positive? No, it can be negative. And does it need to be symmetric about the y-axis? No. I mean, it'd be nice if it is. It makes our life a little easier. So I think it's just these two. And this would just be definitional. Okay. Let's go on here. So now I've got a mean of 20, a standard deviation of 5. What's the probability that the value is above 26? Okay, this one's not too bad. So it would just be the 26 minus 20 over 5, which equals 6 over 5 equals 1.2. So that's my z-score of 1.2. We need to find out what that value is. Sorry, I don't want to keep going back and erasing stuff, so I'm just going to look on my own here. So you should be going to the appendix, page 409, back to those tables, and I'm going to be looking for 1.2. 1.2 has a z value of 0.8849, so that would mean that remember doing this before, remember? Are you kidding me? Oh, thank God. Okay. So that would be 1 minus 0.8849 equals 0.1151. So let's just hope that that's the case. Yeah, and that's the case. Okay, I don't. When I'm doing these, I'm not trying to say these are all easy. I'm just flying through these here. I'm just trying to give you some good hints and kind of walk you through the right answers here. This is largely definitional, and so there's not really much I can say here. If we're trying to find an interval, it is that area under the density curve between A and B. There's nothing more I can say here, and that should be correct, yeah. So that's just definitional. Normally distributed. With value x between 22 and 15. Okay, I'm just going to pause here 1 second. Okay, let's get back to this here. Sorry about that. I had to take that call. So let me, sorry, just give me a second here. Okay, so mean of -20, standard deviation of 5, probability that our value is going to be between -22 and -15. So we need to find, first step here is going to be to find z-scores first, so let's start with that. So again, I'm going to use the tables here without going back and forth. That way at least it'll keep things a little cleaner here. So our general equation here is going to be z equaling our x value minus the mean over the standard deviation. So z is going to equal -22 minus -20 over 5. So that'd be 2 over 5, which is 0.4. And then we've got z equaling -15 minus -20 over 5. So that's going to equal 1. Okay, so we need to find now the z for 0.4 and the z for 1. Okay, so that puts us at sorry, it's -0.4. -0.4 z1. Okay, let's look at the table here. So -0.4 is 0.8413. And we're going to subtract from that for z at 1, which is, sorry, z at -0.4 is 0.34 0.466. This is our z at 1, subtracting z at negative 0.4. And that's equal to 4967. Okay. So that's right there. Okay, now I'm going to have to get rid of our drawing, so I'm sorry, but you can rewind the video to see this part. Let's make sure I was correct. And there we go. Okay, let's look at number 9. Normally distributed, mean value of 36, standard deviation of 4. Probability, what is the value of x for probability 0.0101? Okay, so we need to find 0.0101 in the table. 0.01, so I'm looking at the table right now, 0.01 0.0101. The closest we can get to it is about negative 2.32. Is that right? Yeah, okay. So what does that give us here? Let's look and work this out. So that would mean that 2.32 is equal to the value we're looking for minus the mean over the standard deviation. Multiply, cross multiply, that gets me 9.28 equaling x minus 36. Add 36 to both sides, and x equals 45.28. Okay. Oh, because it's not less than or equal to. Okay. So yeah, so when I was doing my distribution here, I was doing the less than or equal to. Here we're just doing, or the opposite would be greater than or equal to. This one is just not equal to. So that's why a little bit of a difference here. So let's hope that that's correct. It is. And then we've got this very easy one here. It should be symmetric across the mean for normal distribution. And there we go. Okay, that ends chapter 5.